This program is designed to allow you to look at the connection between the force normal that is felt by a person on a space station and the characteristics of the space station. This force normal that will be experienced by the person on the spinning station will feel to them indistinguishable from the force normal they are accustomed to on Earth. The only real difference will be that we can adjust the value of the apparent gravitational field that is causing this force normal. Now realize this force normal is not really caused by a gravitational field, but it's caused instead by the floor of the space station pushing the person into the circular motion that they are experiencing. So when the person is at the lowest point on the space station, the floor of the space station needs to push them toward the center of the circle. This will counteract their natural tendency to continue moving in a straight line. So we can adjust different properties of this space station and see how the force normal changes as a result. So we can change the mass of the person. When the program loads, 10 pre-built masses will be automatically generated, and the person can cycle through those and see how the force normal changes as a result. There will be 10 radiuses that the student can cycle through and see how these radiuses also affect force normal. And finally, there will be 10 different speeds that can be created for the space station. These speeds are not directly given to the student, but the student must use their timer to figure out these speeds. So we will start timing our person when they reach the highest point of the space station. And then we allow the person to go through a certain number of revolutions. One revolution should be sufficient in most cases to get an accurate value for the speed of the station. In fact, half a revolution might also be appropriate. So I'm going to stop when this person reaches their lowest point. And based on the time that I just measured, I could find the linear speed, the angular speed, the revolutions per minute, or the revolutions per hour, depending on how I would like to have the students measure and calculate the speed. If I'm doing the linear speed, since I allowed it to go through half a cycle, they should use the distance as half the circumference divided by the time. If we were using the angular speed, they would have gone through pi radians in 17.3 seconds. If they're doing revolutions per minute, they should just scale up from half a revolution in 17.3 seconds to the number of revolutions they would get in 60 seconds. If they're doing it per hour, they would scale up to 3,600 seconds. Regardless, students should look at the connection between the force normal, the person's mass, the size of the ship, and the speed of the ship in whatever method they'd like to for calculating speed. Students might also be interested in looking at how the apparent gravitational field changes. If they're doing this, they should take the force normal that they measured and divide by the mass of the person that they were using. They should see that this gravitational field, again, apparent gravitational field, is not influenced by the mass of the person, but is influenced by the size of the ship and the speed of the ship.